G'day guys, I've got a Minelab Super Gold Search Mono, which is a 8-inch coil, and I'm going to pull it apart and modify it to see if we can make it better. And this would apply to any coil. First of all, we get rid of our pincher cable destroyer. Now, on this cable, if I can get it up without pulling the tripod over, these mono cables are very long. So what I'll be doing on this one is where this pinch point is here. These things are a bloody disaster on every coil they've ever been on, because people tighten them up, got a grommet in there, and it cuts the cable and breaks all the braid. The coils go noisy. It's like, I don't know. It's a bit like, I don't know. It's just a disaster waiting to happen, and it is a disaster. Anyway, what we do on this hand, bear with me, I'm going to put it against my chest where I haven't got the camera sitting. Pull off the skid plate for a start. That's had a lot of use on this coil, as you can tell. So I'll stick that over there. And what we have to do with this coil is we have to break it around here. And these have been glued together with acetone. Normally it's acetone. It can be a ABS cement, and it also could even be ultrasonically plastic welded, which actually heats up the plastic between here and this bit, so it all sticks together. The trick is to try and make it hermetically sealed. Like I said before, it rarely is, and it'll suck water in if you heat it up and shove it in a puddle or in water. That's just the nature of the beast. But what I've done, and you've got to be careful, I'll put my disclaimers in now on this. You have to be careful. You can use a Stanley knife or some knife. What I use, I get this is me. This is what I, oops, banging the microphone. This is what I do, okay? I do this, and this is the way I do it. This is not saying the way you should do it. As far as I'd say, you shouldn't even try doing this, because you're probably going to, if you're clumsy and you're not really experienced with hands-on, cutting and stuff like that, you might slip and cut your fingers off or slice your arm and bleed to death. I don't know. But I'm just saying, if you're going to do this, be damn careful. And if you can, you only need about 5 millimeters of blade sticking out. 5 millimeters. So with that, you're not going to kill yourself if you slip. I'm just being, overly cautious with this, because I don't want anyone coming back saying, you said to do this and I injured myself, so you're liable. This sort of rubbish. It does happen. So I'm telling you not to do it. Okay? Don't do it. Just watch me do it. Watch me make a git out of myself by slipping and cutting it. Anyway, I'm trying to just emphasize that this is dangerous. Anything with sharp objects is dangerous. So that's a sharp blade. I've wrapped it with handlebar tape, and I've also got an old rag around it as well, because it's really hard to keep the pressure on it, but it's a controlled pressure. What I do is I push, but I'm also pulling back. It's like push motion and pull back. Some of these are really tough to undo. Some of these are really easy to undo. Well, to get that off. And it's a luck of the draw. If you do not feel competent, or if you are not competent, and if you are, clumsy, don't do this, whatever. And like I say, don't do it anyway. Maybe you could take it to some specific shop that does this sort of stuff, plastic work or whatever. Anyway, I'm going to do it the way I do it. And this is really horrible. This is why I say don't do what I do, because I do it this way, and you should do it away from yourself. So the correct way to do it is away from yourself. What you got to do to start this off, don't try and cut into it. It won't work. Get the blunt part of the knife blade and work it back and forth like so, right, until you make a groove in there, and it'll stabilize the blade. I'm going to tell you how I do it. So anyway, I do that many times. I get in there, and once I'm in there, I should be able to get in this one fairly easy because I've already done part of it. When you get in there, see how I've got that in there like so, right? I'm going to work this way, right? Safe. It's safe. Don't put your other hand in front of the knife like this business. Don't do that. You'll cut yourself. Blood will go everywhere. Anyway, so when we're on here, okay, you've got to keep the blade of the knife flat with this bit. It has to stay flat. Otherwise, if you push down, it'll cut through the this bit here, the top piece, and you have a big cut through it. Or if you go in, you're going to gouge the inside of this. Anyway, what I do is I hold it tight and I basically work it around like so. And it takes a while. It's very high pressure and you get a sore hand doing it. So that's what I mean. You've got to be careful. So you go around, but you can see what I'm doing. Okay. Now I cheated with this. I've already done it, right? But I put it back together to show you guys how to do it. So, you know, it goes right round easy. So it's not that easy in real life. It is really difficult. As you can see where it's got little, I don't know if you can see, but it's got little crack marks along here. That is where it's had some sort of bead of material. But the way to do it is you get this and you back of the knife like that, and eventually it goes through. Then you've got a working point. Don't try and go through, you'll just wreck it. Right? It's really critical to do this grinding action until it goes through. And it might take a little while to do. But anyway, what you do is you go around and you know, don't angle it up. It'll just slice straight through. Don't angle it in. Keep it like that. That's why I say it's sort of half specialized to do. I've done this many times, so I can do it, right? And if you feel that you're going to go and slip off the reservation, don't do it. You know, keep that tight, keep it wrapped up. Don't even have that much exposed as what I have. But I'm using that as a guide on there. And I only really have to go in that far. So I could have, you know, another couple of millimeters, but it is what it is. Just be careful. Don't go and push like mad and slip. Try and push it like you're only moving it 2 millimeters at a time. You know, like wiggle, 2 millimeters, you know, maybe change angle, 2 millimeters. It's like that. So if you do it in very small increments, you're not going to go and do these big, massive cutting excursions and fly off and go, you know, through there, because it will happen. This stuff cuts really easy. So anyway, I've been right round this. Now, I've put it back together. It's still tight. I'm going to put it on the chest and pull it apart. Oh, dear me. It's still tight, but I'll give you a look at all of it. This, you can fix all your old coils, no matter what they are, especially monos. Monos are easy. Okay, first of all, have a look in here. Now, I've been saying this for a long time. Can you see all this carbon here? You can see it everywhere, okay? That's worn off this carbon plate. This is what happens. And when it rubs through, it hasn't yet on this, but where it goes shiny, eventually it'll rub the carbon away and it'll just leave the paper. This is just some thick card type paper, nothing special. And what happens if the card is worn away, like not the card, but the card can wear away, but if the carbon is gone, right, you put this on the ground and you ground balance it, it won't ground balance. It will, the ground to the to this won't be enough to shield the internals from the change in capacitance. Two plates doing this, you know, low capacitance, high capacitance, and you're doing that, it's just going straight through where it's worn and affecting the winding, changing the winding, the capacitance of the ground to the winding. It will sit there and go woo, woo, woo all day long. It won't ground balance. So a lot of difficult ground balance problems are usually the coils, okay? People love blaming the detectors, but if it wants to ground balance a particular amount, it's usually the detector is going to ground balance. It's usually the coil that's at fault. Anyway, we got here. So we undo this dastardly thing here, this cable gland. And here, it's got the little rubber thing in there. Or did I pull it out and chop it out in disgust? Because I hate them. My personal opinion, I hate them. They are just coil damages. And I'll show you why when I get this out. I'll hold the plastic and push that. You could put a little bit of silicone spray here, make it easy to push out, but I can just do this. But you have a look at this and I'll show you. You know, when I get it out, there we go, that's probably enough. Have a look at the cable there. If you can see that, I'll see if I can get the white behind it. You can have a look at that. See, it's crushed in. That is very, very detrimental to the coil cable. And actually, I'll chop that out because I'll redo the cable on this and we'll see how many strands it's broken in that vicinity there. Because if you break strands, first of all, you're destroying your shielding for a start. Also, it's a conductor element. It's a return path for the current going into the coil, and thus you won't be able to energize the coil properly. So it'll be weak and it will be noisy. So a lot of old coils, people think, you know, oh, new coils are better. No, it's because the old ones are damaged, right? And the new ones probably get damaged after a while too. But thank God they've got rid of this on all the new coils, as far as I know anyway. So I'll get rid of that. We don't want that. And what I'll do, I'll just banging the tripod because I'm a bit crammed up here. We'll get this, and I'm going to peel this apart and I'll show you how to do that as well. This will be a complete pull down. It's going to be probably a long video. So if you get bored, skip ahead. Or do what I do, do something else and let it play in the background. And I'll just chat it out. But anyway, we go here. It's like cutting out a cancer. Don't worry. Ah, dear, things I say. Don't get me going on about metal detectors and cancer. Someone asked me about that. And so many detectorists that I know, I'm not joking. So many detectorists have died of cancer. I'm not joking. It's a bit strange. Anyway, I've got that there. Let's prove a point on this and see if I'm correct that all the braid will be broken. Anyway, what it does, it's an impedance bump anyway. It squashed the outside in to the middle, and normally you have a spacing with that foamy. Look at that point with that foamy looking dielectric there. Well, that foamy looking dielectric is not foamy anymore. The braid, which is just under that black sheaf, is squashed very close to the center core wire there. So you don't want that. You want a good distance there. You want to keep the capacitance as high as possible as it slows down your signal. Anyway, I'm going to put these little goggle things on so I can get right in so I don't stuff it up. What I might do, I'll slice it down with the blade. I've got to be careful doing this. If I go too far in, I'll cut the braid and that'll be the end of that exercise. But I'll do it anyway. We'll see how we go. I usually go a particular, like 0.5 millimeter in, and then what I do, I just peel it like peeling a banana. God, it's hard. Where it's crushed in, it's gone really hard. And I don't even know if it's gonna, oh yeah, come on. It's like, it feels twice as hard as the rest of it. It's been under compression. Okay, I'll try and undo this and see if I can split it. Not there. I'll see if I can do it here. Oh, there we go. It's a bit better. I only want to get on this. Oh, dear me. There we go. It's coming apart like a banana. So this will be proof of the pudding. Okay. There's the black stuff. Now, on here, we have some sort of cloth tape. And oh, it's going to go everywhere. Hang on a sec. I'm trying to grab it. Normal, yeah. Some of the strands are broken, but not all of them. Those ones just come away out of my fingers there. So yeah, there's probably only about 5 or 6 strands that are broken. Most of them okay, but you know, that cable gland wiggle, 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 and it will just break. Anyway, I'll get rid of these because they are a nuisance on the bench with electronics. So the interesting bit now is how do we get all this apart? Now I'm going to point out what is what in this, okay? This top plate here with the carbon on it, which is also, there's a wear, it's got cardboard sticking there, and that is from, oh look, it's had water in it too, I think. It looks like there's some brown stuff in there. We won't speculate what the brown stuff is too much, we don't know. But see these strengthener bits of the plastic, all they're doing is embedding themselves into the carbon. Okay, it's not so bad on top of the coil, but underneath it's a real problem. So you can see the shape. The shape of that plastic is like this and there. So it's actually cut in. You don't want that. We'll fix that up and paint it over. The other thing you want to know, this carbon bit here with the masking tape around it, if I look here, they cut it like, well, it's a big circle and they cut about 5 millimeters out. They cut it like this way, snip, 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 snip. I'll show you when I get it apart. And it's like it's fanned out, so you can bend it round. The other thing too, the same thing here, and that's the top one is sitting over that. There is no continuity between the top carbon here and here. It's actually just taped. It's not painted on or connected. The connections are done here through a very small 0.12 millimeter odd tin plated wire, which actually runs just under that masking tape there. And there's a hole punched through, and normally the wire will be there, and it'll come out here. And so what we've done, if I look at this, the geometry of this one, the ground or the braid connection is in here. They've soldered the this little wire to it. You don't want big thick blobs of solder and things, it stuffs the coil up. So the little thin wire is pushed onto this. This is your connection. The little thin wire here connects to this, goes through a little hole here, and then comes out here as a continuation and then stops there. So that is how this one is grounded, and that one is grounded through this little tiny wire. It's very important. But don't join this with this on the peripheral of the coil. It is separate. It basically is like you know, look at the camera. It's like that and like that. They're not. There's no join. It's just, you know, the inner paper here is just resting on the carbon. A little bit of an overlap still acts as a really good Faraday shield, and you don't have any you know, loss of energy return signal through a massive big shorted turn. If that was all painted across there, which some coils are, if it's low ohmage paint, it will make the coil a little bit less sensitive than what you'd really want in some circumstances. It's good for noise. It'll probably get rid of a lot of the noise, but anything around here, which is a continuation, is a shorted turn because the wires are just there, the coil. Just think of how, like I always say, think of how transformers work. Wire, coil, and another coil of wire. And if you put them together like this one's going to try and put energy into this. If this is just a short circuit or resistive, it'll collapse the field generation of what you want, and also short out the return signal. So that's how that works. Now, I want to see a lot of cases this masking tape stays sticky. Let's see if it does. If it doesn't, I'm going to have to cut it. And what I might do, rather than cutting it, I might try and put some isopropyl alcohol on it to see. Now, if I'm going to look very carefully at this, we have the outside one. Sometimes these are put together differently. But what we want to do here is I'm going to find the start. And the start on this outside one, which covers everything up, is here. So I'll just pick at it and see if it comes up. Sometimes you're lucky, sometimes you're not. It just depends, on the day, the tape, did it dry out and whatever. Okay, it started at the top. See, I was starting at the top because it's folded over. I'm just getting it off like that. It's on the other masking tape, which is good, because if it's, you got to be careful if it's on the carbon, because you can pull the carbon off, right? But that's easy to fix because all you need is some carbon paint, guitar cavity paint, and the bits that you wreck, just tape over them. Okay, so that stops there. Now let me have a look at this. Now I'm going to pull it on the carbon. Have a look. There's some carbon stuck to it, but it didn't rip it to pieces. Now, don't pull it like that. Like that. Don't pull it like that. Pull it on an angle. Very slowly, and make sure it doesn't bite. Okay. We've still got a little bit of carbon here, but it's only taking off like a powdery layer. I don't think it's any, yeah, it got me there. There you go. It pulled the carbon off the paper there. It's no big deal. We can fix that. But if you can stop that happening, all the better. I'm going to try, I have never done this, but I'm going to try putting some isopropyl on the tape and see if it comes away any easier. I wanted a little bit, and half the can comes out, but we'll just see. I don't know if it makes it, no, it actually feels a little bit looser, but it's still pulling a little bit off. On these high bits, it's actually taking it off. I mean, you can chop all this off and make your own, and paint it up nicely. But if you want to save your paint, do it this way. Actually, what I'll do now, I'm just going to get some isopropyl alcohol. I'm going to put it right where I'm pulling it. Let's just see what happens. Let's go a lot easier, actually. So that might be a trick. The isopropyl probably won't hurt it, but I want to speed up this process. That's why I don't want to be here for 2 hours pulling a coil apart, as you're probably well aware. Okay, well, that's all they've used on that. So that's just masking tape. You can keep that or chuck it, whatever. Okay, it's grabbing it here on this bit. So I'll put some isopropyl on it. Just tease it bit by bit. You can see the gluey bits wanting to let go. There we go. So, you don't have to use isopropyl. You get away with methylated spirits too, probably. Just be careful what you use, because there are some stuff that'll eat the foam. Don't use acetone. Do not. So, I know this is a tedious thing. I should just do this and edit the video, shouldn't I? But I don't do any editing. I'm just, it's just raw. I don't do editing. Do you know why I don't do editing? Because I don't know how to do editing. I have no idea. I've never done it. It's not my bag. So, you know, hey, if anyone out there wants to volunteer, let me know. Oh, dear me. So, anyway, this is the way we're going with this. If you really want to, you could just knife it off, but I'm trying to do this so you could actually save all the bits and pieces and put your coil back together. If this gets too long and it turns into a real pain, what I can do, there's no graphite on that paper there, and there's none on the sticky, so it was never there in the first place. So something to be aware of. Back and forth. I could break this up into multiple videos, but then that's probably tedious. Just skip ahead. It's no big deal. Just skip ahead. If this is just a process. That's all I'm going to be doing for probably the next couple of minutes, just on here. But in the meantime, I might tell some funny stories. I've got a few funny stories. But then, people want to know how to do this, so I'll stick to it. I am known to go off track. It's a fair whack on there, isn't it? I can go faster when I hit the tape. I got to slow down when I hit the cardboard with the graphite on it, or carbony paint, whatever it is. It is a graphite-based material. I could just rip off the band-aid, but it'll take all the carbon. So I don't. Bye-bye. That's on the floor now. Can't fall any further. That's what my old man used to say. Leave it there. Can't fall any further. Or was that school teachers? Or probably all of them. Oh, dear me. Yeah. The thing with isopropyl, it evaporates really quickly. I could just go like this right around, but by the time I get to where I wanted to go, it's probably all gone. But yeah, maybe it soaks through the paper. I've never done it. I've just done it this way by hand, and just if I pulled any of the graphite, I just touched up later on. Yeah, I don't know if that made it any easier or not. It comes off the other masking tape really easy. Maybe I should have already have done this and made it faster, quicker. I know why. I haven't fanned this bit here out like so. I'm just pulling it straight, so it's working. So we won't worry too much. Maybe I could attack it a bit faster, but I don't want to rip the graphite. Just because I know if you guys do this, you might not have the paint, and you'll curse if you pull it off, because you won't have a means of replacing it, and you'll have to go and buy the stuff. But you should buy a little bottle of it anyway. It's carbon paint. They use its technical name used to be Aquadag, believe it or not. They used to use it on cathode ray tubes out of tube TVs many moons ago, obviously. And I don't think you can buy it, but they have it for guitar cavity. It's for shielding. You just paint the internal of the guitar cavity. Okay, now we get round to this bit here where we've got to pull this off. And if you're going to reuse it, you don't need to pull it all the way off. Just pull it there, and this will come off as a pancake. So maybe I'll just give everything a little squirt. If it's good, bad, or indifferent, I don't know. Hopefully it just helps lift the glue off a bit. It can't hurt anything, isopropyl, because it just is inert, doesn't leave a film, and just evaporates away. So let's get down here nice and low. I'll try and pick it near this on top of the other tape and see if I can get it to come up. I hope you can see that, but I've just got a lip on it like so, and it's bit of glue sticking there, bit of tape, residual tape off. Don't want you. Okay, so we get that to there. We pull it off there, and you can see there that it's free and just stuck there. You can just leave that there. You can reuse this tape. It's very, very sticky. It's pancaked anyway. It's not going to come off, and it doesn't move. But you see the isopropyl I put on there. It's already gone. It's all very vaporized off. So, you know, if you wanted to, you could cut it. But I'm just, you know, being pedantic, saying, well, this is the way if you wanted to save it. So yeah, always start it on top of the other masking tape, and very carefully stick it back like so. And again, we can just peel it back. I'm just doing this very slowly so I don't rip it. And don't pull very hard here, because you'll have that. If you can see how this is made, can you see how it's this one actually isn't cut by the look of it. This one's just got inner folds. It's been folded back on itself in here, so it goes around. So you'd have a former, and you'd hold this down tight and push that around, and that's how they've done this one. Normally they cut it. It's all got little cuts in it all the way around. Maybe that's later coils. This is a fairly old coil, and they thought, you know, they just cut it. It might be quicker. But on this, look, I'm going to speed things up a bit, right? Because this is just bonk, over it goes. I'll be here all day. Now, if I get this here, my blade's a bit blunt, but anyway, look, you could cut it like that. Makes no damn difference. You know, masking tape is cheap. Just leave that on there and just go over it again. So you can do it this way too. I've done it this way. Just don't cut into it. There you go. Around. Maybe this is the way I should have done it in the first place. There you go. Around. Bear with me. We'll have this off in a second. I'll show you the little critical bits. Okay. So you're seeing many ways of doing this. The slow way and the not so slow way. I'm not going to say it's fast, because it's not. That really is dug in there, so I've got to be careful. There we go. So yeah, that's very iffy there, but that's all right. And we're back around to the sticky. Now, I think I've got it all off, have I? Probably, yeah, look, it all wants to pancake away very nicely. I hope I got that in camera view, because I'm looking at what I'm doing. I'm not looking at what the camera's doing. It makes it difficult. You need VR glasses or something so you know what you're doing. Okay, here, this wire. Now, oh dear me. I'll see if I can get him up. I should be able to. You're sitting on top of masking tape, and you need long pointy fingernails, which I do not possess. Okay, off she comes. Now this is where you can rip it very easily. If you want to be really clever, push it right back on itself so it can't lift. Okay, see how I've got that. Have a look here. I'm pushing it down on itself. It's less chance of ripping the carbon off when you do that. Okay, we don't want to rip the carbon off, but if we do, we can repair it. No big deal. There we go. We get onto that. Bonk, off she goes. Now, what you got here is you've got the end of it, hang on, let's have a look. That's just the end of the wire here, and you got where it's held down here. And if you have a look, this is tin plated wire. I'll show you in a sec when I get this bit off. I've got to be careful here because where it's punched through the hole, it can have furry ends on the paper, and it can catch, and you can rip a bigger hole. Just do it very slow. Yep. Okay. And I'll show you exactly what I mean. It's trying to do exactly what I said. Okay. See, if you can see there, it took a piece of shielding with it, off a bit of carbon on the paper, just at the tip of my finger there. You can see that. And if you look on there, that's done that there as well. But no big deal. No big deal. We can fix that with a bit of paint. If you have actually look at this wire here, okay, what they've done is that's just tin. It's going to be tin plated wire. Don't use copper wire. Use tin plated copper wire for this. And they've painted the wire with the same carbon, and they've tried to tape it down so it pushes hard on this. What I actually do, they've tried to paint it as well by the look of it. But I get the Y shield I use, or you can use the guitar stuff, and you put like little blobs on it. Hold it down with something, and and put blobs on it, like blobs of carbon paint, so it is like a little mountain sitting over the wire, and it won't come loose like that. That just, it'll still work, but if it moves, it'll make noise. You don't want that. So anyway, on this one here, I'll just pick this one off, free up the other end. I could probably just pull it from under it, but I'll take it off. Hang on a sec. It is like ripping off a band-aid. But you don't want to do this too fast because you'll take skin with it. Okay. And I'd say in the middle there, what I might try, so I don't make if there's any hole, I don't think there is, but I'll just whack it with some isopropyl under there, just to de-stick it a bit, maybe that, oh, there we go. Actually, right there, that actually worked a beauty. Come on, let go. Okay, there's our wire. And if you can see, the other end of that's just silver, painted. Paint the whole thing. I mean, it's neither here nor there. Okay, we do this. We stand the wire up, if you can see that. Hopefully you can see that, where my hand is. Keep it vertical, okay, because you want to take this off. Now, sometimes they're glued on, and I've had everything from hot melt glue to PVA glue put on these to stick it to the foam. Now, this is where it can get dicey. Sometimes it just pops straight off, but we'll have a look. Okay, I've got to sort of stick my head right in here and go and feel for a bit, because I don't know. I can't even see what sort of glue. I've got to stand up and stick it under the light for a sec. Okay. I'm going to risk it. I'm going to throw some isopropyl down there. I don't know if that's a good idea to do on the side. I've never done it, but we'll see. What you probably really want to do this, so you don't crease the paper, is you want something like a butter knife, okay, or a very, very small, trowel or something of that nature. But the trick is, don't bend the paper, don't make it go up. Just look, I'm just pushing my fingers in there. See if I can unstick it. Just leave a bit of pressure and just see if it comes away. Because when I'll explain right now, but just in case I stuff it up, the glue goes on like this. Zit, 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 zit. That's how they do it, right? It's not smeared over the whole thing. all you've got to do is crack it off those glue lines and it will come apart. I'm just trying to figure out exactly. See, if I can get onto one of the bits of glue that's very close to the edge, I can work back of it. Okay, here we go. If I'll open this up and I'll see if you can. Oh, I might bend it too much if I do that, but I can see the glue. I'm breaking some of it off. It's some yellow glue on this, but we'll soon find out. I'm working it around. Look at this. I'm sort of working around, just a round motion, and it's becoming less and less adhered. And then we've got some bits here that it's really stuck. Okay. I'm not joking. This glue is coming off. It's making those sticky lines. Fill the whole thing up with isopropyl. Maybe the fumes will do something. Oh, here we go. It's unsticking. Round we go. A bit more. I think you just got to walk it round. I should be using a butter knife, but I haven't got one. Oh, look at that. There we go. Saved it. So you just caught a little bit there. But that's nothing. You can just squash that down. Like I say, this wasn't the the donut glaze. This was a spiral one. So different operator on the day. So that's this, and you can see how it all fans out, and it's just basically squashed up. That's that part of the coil off. That's actually the bottom part of the coil. So that can go there. And here you'll see, yeah, that little bit there just held on. Maybe that's where they started the glue or something, and it really grabbed. But we'll just flick this off. It should come off easy. Bit of masking tape, and you can see here where the coil wire just gone through, hole through there, hole through the foam, a line gouged out there. If I push that, there it goes. You can see that, and the connections are on this side. Connections are on top of the board. So it's a matter of just doing a reversal of what we just did. Take that off so the wire just pulls straight through, doesn't catch. But let's just have a look at the tape here. How they've done this. Okay. This bit here, you can just put fresh masking tape on. It's no big deal. It's pretty tough masking tape, actually. Anyway, it's like so. And if you can have a look at that, that top bit there is just a pancake. So you can just pull this off. As long as it doesn't race back over the top here and rip it, anything like that, I should be able to just easily get that off. But how about what I do? I'll make it really easy. You can do this yourself easy. Okay, where I've started, your blade goes in there like so. This is fairly easy. Just cut the tape. Don't cut the foam. I'm trying to do it in front of the camera. It's damn awkward. But you want to just work it round there. Oh, wait, get in there. I'll do it this way because it's a lot easier for me to do. Just keep it resting on the foam. There we go. It's got glue as well, so it makes it hard. But this is coming off quite easy. Get back in there. Isn't it tedious? But you can make yourself a really good coil because no one's going to make a better coil than yourself. Because you're going to take time and do it nicely. Just where that tape is doubled over, it can be a bit tough. But this should come off as a pancake. Yep, I'm just going to take this off here, that little bit of masking tape. See, people are scared of coils. Don't be scared of coils. I say, push that down. pull it back on itself so it doesn't rip off. There you go. You didn't know a coil was 90% masking tape, did you? If I touch the carbon with the metal, it makes a silver. It looks silvery. It's not doing any damage, it just looks silvery. Well, I've got to get here. If that's where the wires come through, yeah, I've got to spray this because otherwise it'll pull out a chunk. So I'll do that. Bit of isopropyl on there. Hopefully that makes it behave. We'll just check. Oh, look at that. Didn't do anything. Shouldn't say that until I've got it off, because the last pull you get overexcited and you rip it. So there's the wire through that hole, comes out there. That's it. Same thing. You can actually do that if you really want to. Grab it. Come here and do that. You can pull it right out, pull it right through. But you do want this disconnected here, because when you pull this up, it'll cut through. The wire will just pull through, and it may cut your carbon. I don't know if it'll actually do that, because I've never yanked it hard enough to find out. Okay, I had that blade in my hand. Oh, there, it's under the scissors. Okay, the trouble with this workbench, you lose track of stuff. Anyway, we'll go up where the wire is. Just start it there. We'll work it round. I'm going to give it a spray of isopropyl, just unglue it a bit, make it a bit easier. Does feel a little bit hot, and because there's a hole and it's all cut round on the cardboard there, it could grab on the fibres of the paper and rip it. So I'm doing the isopropyl just so there's less chance of that happening. There we go. Last bit of tape. That's how she goes, like so. Now we just want to get this top pancake off, and I hopefully haven't glued it on like hell. No, come on, off you come. All you gotta do is get it started. Oh god, I think they put some good glue on this. It feels very gluey. It's very stuck on right on the edge all the way around. But here we go. I was going to give it a big blast of isopropyl alcohol. That's way too much, but anyway. Maybe blades or scissors. Something like that can help in this regard. Let's just see. I've never done it with scissors, but I'm going to do it and to see what happens. My god. Okay, they must have used the person who was heavy-handed with the glue gun on this one, because it's really stuck. Oh, is it stuck? I'll go around anyway. Just going to make sure. Don't push too hard as you go through the paper. But, you know, there's little gaps, but it's really stuck around hard. Dear me. No, it really is stuck. I've never had one that's like stuck like this. This is a doozy. But we'll get there. We'll get there. I can see the glue in there. Let's see if I can spray into it a bit. Get something happening. I think the trouble is I'm trying to do too much at once. And something flat like that, flattish, it might be able to put enough pressure there. You could probably poke a whole heap of things like that and just leave it. Eventually it might just pop. But I want to get through this side. This is where all the interesting stuff is. You know, for me, it's really just easy. I just rip it to pieces and just paint another piece of cardboard and put it there. But I'm trying to do this. I'm trying to save it as a project sort of thing. And you can feel the glue. There you go. Poke it, poke it. I think a butter knife would actually work. And I don't really want to walk out and get a butter knife, because it shouldn't be that damn difficult. Yeah, I think if I just do that and work it round, it'll probably come off. but you get the gist of it anyway. You're sort of seeing what I'm doing. Yeah, it's got a lot of glue on here. They've done a job on it. They said, look, Woody's going to try and pull this apart one day. Let's make it really difficult for him. Oh, God. Well, someone's going to try and pull it apart. Yep, there you go. I went through the paper there because the glue is hard right there. So there you go. That's, you got to put paint over that, a bit of masking tape, and paint that as well. So yeah, this is being a pain in the proverbial, and it is what it is though. I could just, give it the treatment. Yeah, but this is how you do it anyway. But yeah, oh my God, it's just really laid on. The other one is really easy. This is difficult as. You can't really heat it up to get it off. God, they've really, I don't know if you can see in there, but the glue, if you can see that in there, I don't know if you can, they've really just packed it in there. So that's how much I've broken off so far. But yeah, I think the butter knife is the way. I don't know if I've got a butter knife. I'm not talking about like a butter knife you use for putting butter on bread. I mean, when those really flat spatula type knives. Do I own anything like that? I did own stuff like that, but I don't know if I own it anymore. Uh, Hang on a sec. I was looking at my tools. It's no good if I'm trying to show you to pull it apart without destroying it, and I bloody will destroy it because that's just crazy. That means you have to go out and get the a bit of that guitar cavity paint so you can fix it. Hang on. Look, bear with me. I'll be back in a second. I was going out and raid the kitchen and get myself a knife of some sort. I need a sharp knife. We don't have a proper butter knife, do we? A butter knife. Yellow handle thing, bony handle, flat blade. Uh-huh. I've done one better. Okay, here we go. A MasterChef knife. This is what I should have used in the first place, but I was just being lazy. And when you're lazy, you pay the price. Anyway, let's see how I go. I'm just feeling the glue. Still damn, got a lot in there. I'm having far more success with this than how I was trying to do it. So we just get the MasterChef knife. Watch out, these are sharp. So just be careful. And I'm trying to hold it hard against the foam because if I tilt it upwards, God, there's so much glue in this. Look, there we go. You get a bit of wire there. I'm going to cut. Oh, look, I'm cutting the paper. Damn it, because the glue's grabbed so much, but it hasn't gone through the carbon. It's made the paper thinner. But I'll get this off anyway. Let's go for broke. I mean, just get off. Come on. And you'll see what I mean. My God. I mean, I haven't gone through it only in that little spot there. It's easy to fix. That's nothing wrong with that. I can glue that back on. No big deal. But if you see here, like I say, look at the glue there. They just did a spiral, right? And this one here sat there dawdling for a lot longer, sticking his glue on. So it just grips like hell. There might be a better type of solvent that can eat this this glue off. I don't know. It could be just a hot melt, but I don't know. If you heat it up, what will happen if you heat it up too much? This foam material will cave in and it'll be a write-off. So anyway, don't worry about that. Look, even if I wanted to, you could rip all this paper off and just paint the damn foam with carbon if you wanted to. Okay, and all you do is just put a little piece around the end there. Yeah, it's probably good enough. Here we go. Get rid of this masking tape here. This is where all the magic happens, and this is the bit I actually want to get into. How long has this been going for? Oh God, 55 minutes. Bloody long. Sorry guys, but there's your coil. There's your windings. This here is the problem area where the wires join. On there, you've got big bits of solder there. What I want to do, I'm going to put some iron core in here over those joins. And what I've got an identical coil to this. And I'm going to do field tests and see if we can tell if there is a noise difference on hot ground. That's the aim of this. So I didn't say that at first, and you know, everyone who's tuned out now is saying, God, he's waffling on. They're all going to miss out, so they won't know. And you know, bad luck. I don't really care. But you know, if you're interested enough to stick around, you're going to find out some interesting things. So yeah, there's that earthing grounding wire, Faraday connection wire. And if you can see that there, it just solders onto the braid of the wire, of the Litz wire. Remember, Litz wire is very difficult to tin up because each strand has lacquer on it, or polyamide, or whatever they use. Best way to do Litz wire is put it in something that's a heat absorber, so that the rest of the wire doesn't get hot, and put it very quickly in a solder pot. And what you want to do then is, as soon as you put in a solder pot and it is hot, you just quench it in I was going to say water, but if water stays in the cable, it's going to cause trouble. But I do water, but I dry it out, let it dry out, just hit it with hot air. And yeah, you don't want the heat running up. It stuffs up the insulation, does everything. So you've got to be very quick, and you only just want to get the solder on maybe 1 or 2 millimeters of length of the wire that you're soldering. You don't want to go and say, oh, I'll put 1.5 centimeters of solder down. It makes it into a big target. You don't want to do that. So that's that there. Now I'm going to lose that and that. So that's what, 1 inch, 2, 3, 3.5 inches of cable, 4 inches, whatever that is in metric. But yeah, when I look at cable, I think in inches. When I look at a lot of other stuff, I think in metric. It's terrible. But yeah, so anyway, what you do now, you can pop this up. You can see that. You can see it a lot easier, a lot better. Up we go. And there you go. That's what you got to do. You can that's a bit of heat shrink there. You can replace the heat shrink with new heat shrink when you do all this. Take that, you know, unsolder it, bang bang. Keep that, poke it through the hole so it connects on here, connects on there, onto the Faraday shield, which is just carbon. Under here is your windings. There's nothing special. This one here, I think, has a type of elastic band around the winding. Yes, it has. There you go. A big piece of rubber around the windings, and you know, you don't really, you can just take that off, put it on later if you want, or if you can get a low dielectric adhesive. Remember the words I say, low dielectric adhesive. There are some around. Most of them are bloody toxic and deadly poison, but you can get this stuff, and you can dab. First of all, make sure the wires are tight in there. Don't make sure they're not loose. You can see them in there. They're nested in there at the top. That's how they go around. That's all nice and neat. They're solid. And the thing is, have you noticed on this coil, they haven't soaked the whole thing in resin and increased the, well, basically dropped the Q of the coil, should I say. They haven't done that. I'm just having a look at the glasses, and this looks like a double insulated with polyamide coating. I'd say by the look of it, if you scratch it up, it goes furry, and you'll be able to tell. Some of it can be like a nylon type material, can be anything in there, but that looks all right. It's fairly thick. This coil would have probably worked really well. Okay, so on here, I'm going to like that. Have a look at this, right? Now I'm going to say, because not everyone knows why you do these in a particular way, but I'm going to hold this over the white paint there. See that connection, the solder connection? It's a big blob. It doesn't need to be that big. Imagine if you went over the ground and that was sitting there, it would sound like, um, half a gram nugget or something. And you're getting a similar response in these detectors too. That is reactive to the ground. No matter what anyone says, that's reactive to the ground, hot ground. Um, that'll generate an eddy signal, and the ground will look at that and probably, give it a huff back at it. It just causes some ground reactance. We don't want that. You make that very small. If you look at how small the wires are here, you can wind that braid into the same size and just even end connect them with a little bit of a fillet, sort of not a fillet, sorry, like a convex bit of solder, a little bit out and a little bit there. You want to make sure you don't cause a dry joint. If it sets properly, cools properly, it'll be very strong. And once it's laying in there, it's not going to get any movement. It's not going to break. So it'll last forever, and it will be a better coil. What I've noticed as well, I might as well tell you this, you've got dead parts of the coil and active parts. This solder join here, okay, if you have that very close to the windings here, that'll be very reactive. The slightest movement, it will sound off like crazy. When you get this towards the middle of the coil, it's also equidistant from every edge of the coil, so anything happens here, the whole coil picks it up. So it's like a center target. You don't want that either. Where you want to have this is exactly halfway between the center and the innermost part of the winding. So you probably want it about here, where my finger is. You want that join there, not where it is, because this is it's not really, we'll call it the deafest part of the coil, because it's far enough from reacting with the windings and far enough from being a central target to the coil. I hope you can understand that. You want to stick it there, halfway between the hole, well, half the radius. How's that? Is that a better way of saying it? There, not there. It's getting too close to the center part of the coil. It will get a lot more overall energy, where here, it's not getting any energy from here, and it's far enough away from here not to get that much just in close proximity to this side. So, tricks of the trade. But that's what it is. So, I've chopped the wire. I've lost that little bit there, but I can put a proper cable gland on that, get rid of that clamp. I'm not going to start swearing, because that's what I think of these. And they are absolute little dreadful things. You don't want it. Because when I get one of these, first thing I do, I get a pair of pliers on these and I loosen them off, because I know it's just going to cut through the cable. Just loosen it and get rid of it. So you got this apart now. Well, I've got it apart, should I say. We pull this out, okay. That thing there, that's basically the same as that. I pulled that off another coil, obviously. I pulled it off that nugget finder. I think it was on a nugget finder. Oh, no, it wasn't. It was on the Double D. It's on the Minelab Double D. So there's your cable. You got your nice cable. It's long enough. It definitely long enough. They're probably about 8 inches too long. It's not going to make any damn difference. So chop that off, poke that through, and get rid of this. I don't want this tape. Oh, actually, I might keep the rubber thing. Don't know why. You just put rubber bands around it. Just get the big pink rubber bands and stick it around the windings if you really want to. It's just to stop any type of wiggle motion on the last couple of strands in case if a strand jumped, see that one there moves, right? If that jumped and went in the gap there, it would just line there loose, and every time you touched anything like tap, tap, it would go woo, woo, right? So maybe you do want to put a bit of rubber around there or tack it with what I said, a very low dielectric type glue. You don't need to go and smother the whole thing in glue. You can just tack it every 1.5 inches or 25 mil, whatever, just so it doesn't move. You don't want movement in your windings. It's terrible, but that's why people nowadays make the detectors go faster. They're more sensitive, and they glue all the windings, and they sort of defeat the purpose of what they are trying to do. Dear me. So with this gadget here, this thing I call it, that one there, it looks like it's glued in. You could just get a big grommet and fit it in there and put the cable through. Actually, that's a very big hole. I would actually look at could you do it? Could you do it? Probably it's enough meat there. It's a damn big hole, isn't it? Like when you think about it. But I would probably fill that and partially drill it with a cable gland size hole here, and put a cable gland. Well, even better, if you get up a bit of ABS, cut it to that circle size and just stick it in there and glue it in, and then just have the center hole to the size of a little bit bigger than what your cable is, and you use a rubber grommet type gland. So it can bend around, and it's not going to bend on a sharp point and break, and there's no compression. Just don't go sticking it in puddles of water. Uh, you know, if you don't stick it in puddles of water, it's fine. It can get rained on. Um, you know, if water wants to get in on these coils, it will. You can't really stop it unless you put like one of these things. Hang on, where is it? This one here. Whoops, God, this is heavy. This X coil, and some of the other coils have it too. I haven't actually checked, but I do think that's a one-way valve. So if you do have something like that on there, I don't know how it comes off, or screws in somehow or other. But if you do have something like a one-way valve, if it could help keep the pressure equal in the coil, so it won't pull water in. It's probably a very good idea. So maybe that cable gland was on that, was it? Oh, yes, it was. Ah, dear me. No, no. Oh, I keep seeing them. But yeah, the new nugget finders are very nicely done. They don't get water in, as far as I know. I've never heard of it. So that's that. And that's a bloody waffle and a half on this. But that is how you would rebuild a coil. So it's just, take all this glue off, cut it off with like, get the knife on it. Actually, I'll just do it because I've got it going and I'm here. You can probably poke under that and get a knife and keep it. Don't lift it, but it's still tacky. But you can do that, and it's going to be horrible and tacky, and it's going to stick all over the knife, and the missus is going to go nuts. But yeah, whatever this stuff is, if you want, there's a trick to doing this too. If it stays tacky, throw it in the freezer, right? And when it all gets really hard, just break it off. It just snaps off. You can just flick it off with something. So that's another trick of the trade. I've done that before too. But I didn't expect this coil here to still be tacky. It's I don't even know what sort of glue that is. It's it's still tacky. It's definitely not hot melt, because that just goes hard as a rock. But whatever this is, yeah, it's It's like stuff we call snot glue, right? Like quick grip or something, maybe. Something of that nature, something out of that family. But it does stick very well, and that's what it is. So what I'll do, I'll rebuild that. It's going to be a damn good coil. I'm going to do the covering of these with the carbonyl type reduced iron cores, not ferrite, right? Not ferrite. It will be an iron powder based material, and I'll actually do some more tests on that. I'll get some more. I've just ordered a stack of stuff coming in for doing some tests, so we'll be able to work out what's the best material for shielding and non-reactiveness in the whole coil design, and that should be really good as well. So yeah, sorry for the big waffly old thing, but I pulled a whole coil apart. You're lucky I didn't cut it from start, because that would have taken half an hour. But yeah, and also when you cut it, depends on how the plastic's done. If you cool the coil and the plastic is very thin, and you put the blade in there, like, you work it through, sometimes it just goes snap, snap, snap all the way, and does a beautiful clean snap all the way around. It comes off quick. And other times you want to put it out in the sun, or what I've done, I've stuck it in the oven at 50 degrees C, heat it up, and that, it makes it more pliable, and you can do it that way. But you've got to be careful you don't slip, because it will just slice through like butter, and you'll have a big gouge up the side of your coil here, or multiple. I've done it before. That was on a 18-inch coil though, because I was just getting frustrated and trying to rush the job. But it can be done. So anyway, that's one hell of a video. I hope you enjoyed it, because I didn't. Catch it.